Bonjour tout le monde. Bienvenue à Area's Creative Tutorial. Today's tutorial is about
operations with functions.
Let's begin with adding functions. Given that f of x is equal to 3x plus 2 and g of x is equal to 4 minus 5x, find the value of f plus g of x. We would rewrite the equation, so this is f of x plus g of x, and replace the value of f of x, which is 3x plus 2, plus the value of g of x, 4 minus 5x. We would combine the like terms, 3x and 5x, so this is 3x minus 5x, and 2 and 4, so plus 2 plus 4. 3x minus 5x is equal to negative 2x, and 2 plus 4 is equal to positive 6. So negative 2x plus 6 is our final answer. Adding and subtracting functions are just similar. This is an example of subtracting functions. Given that f of x is equal to 3x plus 2 and g of x is equal to 4 minus 5x, find the value of f minus g of x. So first thing that we would do is to write the equation. F of x minus g of x. F of x is 3x plus 2 minus 4 minus 5x. Okay, so we would combine the like terms, so that is 3x plus 5x, okay, box, and minus 2 minus 4. 3x plus 5x is equal to 8x, and 2 minus 4 is negative 2. So 8x minus 2 is our final answer. Let's move on to multiplying functions. Given that f of x is equal to x squared minus 3 and g of x is equal to 2x plus 5, find the value of f times g of x. So we would write the equation f of x multiplied by g of x. F of x is 4x minus 1 and g of x is x plus 5. This equation is an example of multiplying polynomial, specifically a binomial. So therefore, we could use the FOIL method. So this is 4x squared plus 20x minus x minus 5. And combine like terms. So this is 4x squared plus 19x minus 5. 4x squared plus 19x minus 5 is our final answer. Let's move on to dividing function. Given that f of x is equal to 4x minus 1 and g of x is equal to x plus 5, find the value of f over g of x. We would write the equation f of x divided by g of x. So this is 4x minus 1 divided by x plus 5. We should always remember that in dividing function, the denominator should not equate to 0. So therefore, we will find a value of x that the denominator will not be equal to 0. Let's say if the value of x is negative 5. Negative 5. Replace it with negative 5. So it's like negative 5 plus 5 is 0. So that is not applicable. So therefore, the value of x is not equal to negative 5. All real numbers except negative 5. This is another example of dividing functions. This is a little bit tricky because we are using radical number, but it is just a piece of cake. So given that f of x is equal to the square root of x minus 3 and g of x is equal to x minus 5. Find the value of f over g of x. So we write the equation f of x over g of x, square root of x minus 3 over x minus 5. We have limitations in the domain because we are talking about the square root of a radical number, square root of x minus 3. So we should have a positive or a 0 value in our numerator. This shouldn't be a negative value. It should be positive or 0. So therefore, x should be greater than 3. And for our denominator, x should be greater than 5, so that it would not equate to 0. So therefore, our domain is x greater than or equal to 3. This is for the numerator. Okay, numerator. And for the denominator, x is not equal to 5.